Welcome everybody. My name is Alberto Marquez and this is a video on the introduction for the course Simulation of AI Systems. In this course we are going to talk about how to generate discrete event simulation and queuing theory. We're going to describe the details of how the simulation packages work also. So let's start with the layout that we have in Blackboard. We are in the Start Here section, and you will find my name, my contact hours, my phone, and a little bit of background on my academic career. And you will see the course objectives and the course schedule. You will see that we have 14 units of learning, and they are clearly defined, and the content in Blackboard is going to match that. We also have a schedule for when these activities are going to be happening. Again, you have my contact information, but what comes important is that we have here our ABET outcomes. We have the textbook that we are going to use, Simulation with Arena by Kelton and Sadowski, now in the 6th edition. And most of you are particularly interested in knowing how are we going to grade. This course is going to be graded by means of 5 tests. I have learned that the more frequent the tests, the students are panic less, they get used to the material faster, and they get used to the testing style. So these five tests are trying to accommodate the past history and how students are more likely to succeed. So each one of these tests are 12% of the grade. Five of them makes a 60% total. The simulation project is going to be 20% of your grade. And in order to match the activities and the units and the test, you're going to have homework assignments, 10 of them at 2% each of them. These are going to be short, to the point assignments for you to practice the particular skill or topic that we're going to be covering. We have a detailed schedule when the tests are coming and how many points you're going to be able to make. The remaining of the syllabus, as it's described in Blackboard, is the standard content for the university in terms of around university, Blackboard, and network acceptable use, etc. So take a look at that for at least one of your courses. It's important. Also important is the policy for dropping a course. If we go to other sections of the course, you're familiar with the course mail and announcement. Particularly for this course, we have, as I mentioned before, 14 units that will have the content of the course. And that's pretty much it. If you have any questions, please contact me. And before I close this, let me show you a little bit of the packet Arena. This is how Arena looks like in the graphical interface, and this is probably one of the simplest projects you can create using Arena. This is just a system in which entities are created and go into a process, and after being processed in some type of machine or other type of resource, it is disposed. We can execute the simulation, and you can see, well, it's running quite fast, so it is difficult to see, but you see how the queue is being formed, run, and set up. And here in the run control, We have animation speed factor. We can reduce that a little bit, say at 10% of what it was before, and select OK. So now when we run it, you have a better, more distinct view of where the entities are going and how many have gone through the system. Let's run even slower. Now there you go. This is what's happening. So if the entities are waiting in line and there is no other entity entering, then they go and start being processed. If there is a line or there is another in the process, then they have to wait. And as you see, the main characteristic here is the capacity to make a dynamic analysis of the performance of the system as opposed to just a static. Naturally, this is a very simple model, but you can create very complex models in which you have different type of entities, like passengers and luggage and airplanes, and all those combined create a very sophisticated and difficult to predict performance, given the fact that all of these have to travel different distances and using different modes of transportation. And that's why it's important to be able to have this skill for an industrial engineer that needs to validate several type of new designs, like plant layouts or the way that the paperwork flows in an organization, in a service organization, or how many servers we're going to put into network or a call center. All those type of activities in which the waiting time and the speed of process combined with the amount of resources that we need to invest have to be pondered into an optimal system design. So this is what we're going to be studying, and welcome to the course, and see you inside the course.